In the early 1900s, deep beneath the mountains of industrial America, there existed a world that most people on the surface never saw. A world of narrow tunnels carved through black rock, where the ceiling sometimes hung so low that a grown man could not even stand upright. Every morning before sunrise, hundreds of miners descended into that darkness in metal cages. The cages dropped fast through deep shafts, the walls rushing past in dim lamplight. When the cage doors opened, the men stepped into a place that felt less like a workplace and more like the inside of the earth itself. The air was thick and warm. The only light came from small lamps attached to their helmets. Every sound echoed strangely off the rock walls. For decades, mining coal had always been brutally simple. A miner lay on his side in a tunnel barely 3 feet tall and swung a pickaxe hour after hour, carving a narrow slot into the base of the coal seam. It was slow, exhausting work. Arms burned, backs ached, and sometimes the rock above simply gave way without warning. But then, something new arrived underground. At first, it looked like nothing special. Low to the ground, heavy, built of thick steel plates, roughly the size of a small cart. But when the machine started moving, the entire mine changed. A powerful electric motor roared to life, spinning a chain of steel teeth that scraped against the coal seam like a mechanical saw. The machine crawled forward slowly, chewing through the rock with relentless force. The sound filled the tunnel completely. A grinding, metallic scream that echoed through the earth so loudly, miners could barely hear each other shout. Mine owners celebrated the invention immediately. This machine could do in minutes what had once taken hours of exhausting labor. Coal production surged. Mines that once struggled to keep up with demand suddenly produced more fuel than ever before. To the companies running the mines, the machine looked like progress. But the miners working beside it began to notice something strange. The air changed. Within minutes of the machine starting its work, the tunnel filled with a dark haze. It wasn't obvious at first, not like smoke, more like a fine shadow floating in the air. Miners coughed more often, their lamps burned dimmer in the thickening dust. And there was another unsettling detail. Every few seconds, tiny sparks flashed from the spinning steel teeth as they struck hard rock buried in the coal seam. The flashes were brief, small bursts of light in the darkness. Most men ignored them. After all, sparks were normal in a mine. But those sparks were happening only a few feet away from something far more dangerous: invisible methane gas leaking slowly from the coal itself. So here is the question that nobody underground could answer yet. If the machine was supposed to make mining safer, why did the mine suddenly feel more dangerous when it was running? The answer was hidden in the air around them. Because the machine wasn't just cutting coal, it was grinding it into microscopic particles, a fine black dust that floated silently through the tunnels. The men breathed it in with every breath they took, and none of them realized that this dust would eventually become one of the deadliest hazards the mining industry had ever seen. The machine had arrived to save their backs from breaking under the weight of the earth, but in doing so, it had quietly introduced a new enemy, one that could not be seen, heard, or smelled. An enemy that would take decades to reveal its true cost. At first glance, the coal-cutting machine did not look like a revolutionary invention. It was not tall or elegant. It did not resemble the towering engines that powered factories or the massive locomotives that crossed the American continent. Instead, it looked strangely compact, low to the ground, heavy, and built like a mechanical animal designed to crawl rather than stand. That design was not accidental. Coal seams underground were often only 3 or 4 feet high. A miner working there could not stand upright. Any machine built for that environment had to move through the tunnels the same way the miners did, low, cramped, and pressed close to the earth. So the engineers created something unusual. The machine had a thick steel body mounted on small wheels or heavy skids. From the front extended a long metal arm, and around that arm ran a moving chain of sharp steel picks. When the electric motor powered the chain, the teeth spun rapidly in a continuous loop, biting directly into the base of the coal seam. Imagine a chainsaw built for stone instead of wood. But unlike a handheld tool, this machine weighed thousands of pounds. Once it started cutting, it moved forward slowly, almost patiently, grinding its way through the coal face inch by inch. The sound was overwhelming. Inside the narrow tunnels, the grinding chain produced a deep mechanical roar that echoed off the rock walls. Miners working nearby often said the noise felt like standing inside a thunderstorm that never ended. And yet, the results were undeniable. Before the machine existed, a skilled miner could undercut perhaps 2 or 3 yards of coal during an entire shift. It was exhausting work, done while lying on one side with barely enough space to swing a pickaxe. The machine could do 10 times that amount. 20 yards, 30 yards, sometimes more. Production soared. Mine operators celebrated the machines as miracles of modern engineering. Coal was the fuel powering railroads, steel factories, and growing cities across America. The faster it could be mined, the faster the country could expand. But there was a problem no one fully understood yet. The machine did not cut coal the way a pickaxe did. A pickaxe struck the coal in heavy blows, breaking large chunks from the seam. Those chunks fell cleanly to the ground, leaving relatively little debris floating in the air. The machine worked differently. Instead of striking coal, the spinning chain scraped and grounded continuously. Steel teeth dragged across the rock hour after hour, pulverizing parts of the coal seam into extremely fine particles. Those particles did not fall immediately to the ground. They floated. At first, the dust was barely visible, just a faint haze in the beam of a miner's lamp. But as the machine continued cutting, the haze thickened into a dark cloud that slowly filled the tunnel. Miners breathed it without thinking. After all, coal dust had always existed in mines. It was part of the job. But here was the unexpected truth. This machine was producing far more dust than the mines had ever seen before. And nobody underground yet realized that this dust was not just dirt in the air. Under the right conditions, it could turn an entire mine into something far more dangerous than anyone imagined. At first, the dust did not seem dangerous. Miners simply accepted it as part of life underground. Coal dust covered everything in the tunnels: the walls, the wooden support beams, the steel rails that carried carts of coal toward the surface. It settled on clothes, on boots, and on skin. By the end of every shift, the men were completely black with it. When they climbed back to the surface after 10 hours underground, they coughed up dark spit and wiped their faces with rough cloths. It had always been that way in coal mines. Nobody thought much about it. But something was changing. The new coal-cutting machines were producing dust in a way miners had never experienced before. Instead of large pieces of coal breaking free from the seam, the spinning chains ground parts of the rock into incredibly fine particles. These particles were so small, they behaved almost like smoke. They didn't fall quickly. They hovered in the air. Inside the narrow tunnels, the dust formed a slow-moving storm that never truly settled. At first, miners only noticed that the air looked darker when the machine was running. Their lamps struggled to cut through the haze. The beam of light from a helmet lamp sometimes revealed tiny particles drifting endlessly through the tunnel. But no one measured the dust. No one tracked how much of it filled the air each day. And more importantly, no one understood what happened when that dust entered the human body. Miners breathed it constantly. Every shift meant 10 hours of inhaling tiny fragments of coal suspended in the air around them. Each breath carried microscopic particles deep into their lungs. At first, the effects seemed minor. Men developed coughs. They cleared their throats often. Some complained about tightness in their chests after long shifts underground. Doctors had an explanation for this. They called it miner's asthma. According to the medical understanding of the time, coal dust itself was harmless. Only certain types of rock dust, like silica, were believed to cause serious lung damage. Coal, they said, was just carbon. It would pass through the lungs without causing lasting harm. But that belief was dangerously wrong. What doctors did not yet realize was that those tiny coal particles did not simply leave the lungs. They stayed there. Over years of breathing dust-filled air, the particles slowly built up inside the delicate tissues of the lungs. The body tried to defend itself by forming scar tissue around the trapped dust. That scarring spread gradually. Breathing became harder. Airways narrowed. Lungs stiffened. And the miners who once worked long shifts carrying heavy loads of coal began struggling with something as simple as climbing stairs. The disease would later be known as black lung. But at the time, no one connected the sickness to the machines producing the dust. The miners believed the real dangers underground were the ones they could see: collapsing roofs, explosions, runaway carts. Meanwhile, the true threat floated quietly in the air around them, an invisible storm filling their lungs one breath at a time. And it was only just beginning. To understand the danger of the coal-cutting machine, you have to understand the men who worked beside it. Mining was never just a job. For many families in the coal regions of America, it was a tradition passed down from father to son. Boys grew up watching their fathers disappear into the mine before sunrise and return long after dark, their faces black with coal dust and their clothes soaked with sweat. By the time those boys became men, the mine was already part of their identity. But the arrival of the cutting machine changed something fundamental about that world. A miner's day began early. Before the sun had fully risen, hundreds of men gathered at the mouth of the mine. One by one, they stepped into metal cages suspended above deep vertical shafts. The cage doors slammed shut. Then the descent began. The drop could be hundreds of feet into the earth. Wind rushed past the cage bars as the walls of the shaft slid upward into darkness. At the bottom, the men stepped into narrow underground tunnels that twisted through the mountain like veins. From there, the walk to the working face could take half an hour or more. Bent low under the rock ceiling, the miners followed narrow tracks where mule-drawn carts carried coal toward the elevators that lifted it to the surface. Eventually, they reached the cutting machine. Before the machine started, the mine felt almost quiet. Lamps flickered softly in the darkness, and the sounds of boots scraping stone echoed gently through the tunnels. But the moment the motor switched on, the environment changed completely. The machine's chain slammed against the coal seam with relentless force. Steel teeth scraped through rock, producing a grinding roar that filled the entire tunnel. In such confined spaces, the sound was overwhelming. Miners, standing only a few feet apart, often had to shout directly into each other's ears just to communicate. Sometimes they relied on simple gestures instead of words. And this created a new and unexpected danger. Before machines arrived, miners relied heavily on their senses to survive underground. They listened carefully for warning signs: the sharp crack of a weakening roof beam or the shifting groan of rack overhead. Those sounds could mean the difference between life and death. But beside the cutting machine, those warning signals disappeared beneath the constant mechanical noise. The machine drowned everything out. Imagine working for 10 hours in darkness beside a roaring metal beast, knowing that the ceiling above you could collapse at any moment, and knowing you might not hear the warning in time. This was the new reality of mechanized mining. The machine had made coal extraction faster and more efficient than ever before, but it had also taken away one of the miners' most important survival tools, the ability to hear danger coming. And in a place where every second mattered, that silence could be deadly. The coal-cutting machine did not begin inside a mine. It began in a quiet office far from the darkness underground. In 1876, a man named Francis Lechner, a German-born inventor, walked into a bank in Columbus, Ohio. In his hands, he carried something unusual, a small wooden model of a machine he believed could change the mining industry forever. At the time, coal mining was brutally inefficient. Thousands of miners spent hours lying on their sides in cramped tunnels, hacking away at solid rock with pickaxes just to create a narrow slot at the base of the coal seam. The process was slow, exhausting, and extremely dangerous. Lechner believed a machine could do that work instead. His idea was simple in concept but revolutionary in practice, a mechanical device with a rotating chain of steel cutters that could grind through the base of a coal seam automatically. But convincing people of the idea was not easy. Most investors dismissed the concept immediately. Mines were harsh environments filled with dust, moisture, and unstable rock. Machines were expected to break quickly under such conditions. However, one man listening to Lechner's proposal saw something different. His name was Joseph Andrew Jeffrey, a banker with no background in mining or engineering. But Jeffrey understood one thing clearly: coal powered the entire industrial world. Railroads ran on coal, steel factories burned coal, cities depended on coal for heat and electricity. If someone could extract coal faster and more efficiently, the demand for such machines would be enormous. Jeffrey decided to take the risk. He invested money into developing Lechner's design, and together they began building early prototypes of the coal-cutting machine. The first models were far from perfect. They were powered by compressed air systems already used in mines for drilling, but compressed air had serious limitations. Pressure fluctuated over long distances, and the machines often lost power in the middle of a cutting operation. Chains snapped, motors stalled, entire machines broke down underground. For years, the project struggled financially. Then, something changed. Engineers began experimenting with electric motors, a relatively new technology at the time. Electricity provided steady, controllable power and allowed the machines to operate with far greater consistency. By the late 1880s, the redesigned machines finally worked reliably. Jeffrey eventually bought out his partners and founded the Jeffrey Manufacturing Company, which quickly became the leading producer of coal-cutting machines in the United States. Factories expanded, orders poured in from mines across America and even overseas. To many observers, the invention looked like a triumph of innovation. A machine had finally replaced one of the most exhausting tasks in mining. But there was one question that no one asked during those early years of success. What would happen when thousands of these machines began grinding coal day after day in the confined air of underground mines? The inventors had solved the mechanical problem. What they had unknowingly created was something much more dangerous, a machine that would change not only how coal was mined, but also what miners were forced to breathe every single day. Coal mines had always carried the risk of explosions. Long before machines arrived underground, miners feared a silent enemy that leaked from the rock itself: methane gas. The miners called it fire damp. Methane had no smell, no color, no warning. It drifted quietly from freshly exposed coal seams and collected in the highest pockets of the mine tunnels. A miner could walk straight into a cloud of methane without realizing it. If the concentration reached just the right level, roughly 5 to 15% in the air, the gas could ignite instantly. All it needed was a spark. And sparks were exactly what the coal-cutting machine produced. As the steel chain of cutting teeth scraped across the coal seam, it often struck fragments of iron pyrite buried inside the rock. When steel hit pyrite at high speed, it produced brief flashes of light. tiny sparks. Most miners barely noticed them. The flashes lasted less than a second, appearing only as quick bursts in the dim glow of helmet lamps. Over time, workers became accustomed to seeing them. They were simply part of the machine's normal operation. But those sparks were occurring only a few feet from the exact place methane gas was leaking out of the coal seam. And there was something else hidden in the tunnels: coal dust. As the cutting machine ground through the coal face, it released clouds of fine black particles that drifted through the air and settled onto every surface underground: the floors, the walls, the wooden beams supporting the roof. For weeks and months, the dust accumulated. At first, it seemed harmless, but coal dust has a dangerous property that few miners fully understood at the time. When fine coal particles are suspended in the air, they become highly explosive. This meant a mine filled with methane gas and coal dust was essentially a giant powder keg waiting for ignition. The disaster sequence was terrifyingly simple. First, a spark ignited methane near the cutting machine. The small explosion created a pressure wave that raced through the tunnels. As that shock wave traveled, it lifted the layers of coal dust resting on the floors and walls. Suddenly, the air itself became fuel. The flame ignited the airborne dust, creating a second explosion far more powerful than the first. That explosion traveled further, lifting even more dust into the air and feeding the expanding fireball. Within seconds, an entire network of tunnels could erupt in a chain reaction of explosions. Mines that had operated safely for years could be destroyed in a single moment. And when these disasters happened, the results were catastrophic. Hundreds of miners could be killed in minutes. Many died instantly from the blast itself, others suffocated in the deadly gases that followed the explosion. The most unsettling part of the story was this: engineers and safety investigators had already warned about the dangers of coal dust explosions. Reports existed, studies existed, but production continued anyway. The machines kept running, cutting deeper into the coal seams, and every shift added more dust to the air of the mines. Dust that was quietly waiting for a single spark to turn the entire underground world into an explosion chamber. Despite the dangers inside the mines, the coal-cutting machines spread rapidly across the industrial world. Mine owners installed them wherever coal seams were thick enough to justify the investment. Production increased almost immediately. The impact was enormous. Before mechanization, coal extraction depended heavily on human strength and endurance. A team of miners could only remove a limited amount of coal each day. But once machines began grinding through the seams, the scale of production changed dramatically. Coal output surged across the United States, and that surge helped power one of the most dramatic economic transformations in history. Coal was the lifeblood of industrial America. Steel factories burned vast quantities of it every day. Inside enormous blast furnaces, coal was converted into coke, a purified fuel capable of producing the intense heat required to smelt iron ore into steel. Without that fuel, the steel industry simply could not function. And steel was everywhere. It formed the skeletons of skyscrapers rising in cities like Chicago and New York. It built bridges stretching across wide rivers. It reinforced the rail lines that connected distant parts of the country. Those railroads were another enormous consumer of coal. Steam locomotives depended entirely on coal-fired boilers to produce the power that pulled freight and passengers across thousands of miles of track. Every train journey required tons of fuel, and that fuel came directly from the mines. Coal also powered the early electrical plants that brought electric lighting into American cities. In the early 20th century, most electricity was generated by burning coal to produce steam that turned large turbines. Homes were heated with coal, factories ran on coal, railways moved coal to every corner of the country. In many ways, coal was not just a resource, it was the foundation of modern industrial life. And the coal-cutting machine made that scale possible.
By removing coal faster and more efficiently than ever before, the machines allowed mines to produce enormous quantities of fuel. Entire regions transformed into industrial centers supported by coal extraction. Yet this success created a strange contradiction. Above ground, the machine represented progress. It fueled cities, powered industries, and helped create millions of jobs. But deep underground, the same machine was contributing to a growing human cost. Every ton of coal extracted meant more dust in the air of the tunnels, more sparks striking rock, more miners working beside machines in dangerous conditions. The world above the mines grew brighter with electric lights and expanding cities, but beneath the mountains, the miners continued to breathe the dust produced by the machines that powered that progress. And few people on the surface truly understood the price being paid underground.
Today, many of the early coal-cutting machines sit quietly inside museums. Their heavy steel frames are motionless. The cutting bars are rusted. The chains that once screamed through coal seams now hang silent beneath glass displays. Visitors often look at them with curiosity. At first glance, the machines seem surprisingly small. They're low to the ground, compact, almost crude in their design. Nothing about them looks especially terrifying. In fact, they resemble ordinary industrial tools. And that is exactly what makes their history so unsettling. Because these machines were not built as weapons, they were designed to solve a problem. For generations, miners had suffered through back-breaking labor, lying in cramped tunnels, swinging pickaxes for hours, risking their lives under unstable rock ceilings. The coal-cutting machine promised relief from that brutal work. In many ways, it delivered. The machines increased productivity and helped miners extract coal faster than ever before. Wages in some mining regions improved. The coal industry expanded rapidly, fueling industries that transformed the modern world. Railroads connected distant cities. Steel built skyscrapers and bridges. Electric power illuminated streets that had once gone dark after sunset. Coal played a central role in that transformation, and the cutting machines made the massive scale of coal production possible. But history rarely tells a simple story. Because while the machines helped build an industrial civilization, they also introduced dangers that were not fully understood at the time. The grinding chains produced enormous amounts of fine coal dust. That dust filled the air of underground tunnels shift after shift, year after year. Miners breathed it constantly without realizing what it was doing to their bodies. Decades later, doctors finally recognized the disease that had been slowly destroying the lungs of thousands of miners: black lung disease, a condition caused by years of inhaling coal dust deep into the lungs. The dust particles triggered inflammation and scarring, gradually reducing the lungs' ability to absorb oxygen. For many miners, the symptoms appeared years after they had left the mines. Simple tasks like walking upstairs became exhausting. Breathing itself became a struggle. By the time governments finally introduced safety regulations and dust exposure limits, the damage had already affected generations of workers. Tens of thousands of miners would eventually die from illnesses connected to coal dust exposure. The coal-cutting machine had helped power an industrial revolution, but it had also left a hidden legacy inside the lungs of the men who operated it. And that raises an uncomfortable question about progress. When we celebrate the inventions that built the modern world, do we also remember the people who paid the price for those inventions? Because every great technological leap carries consequences. Some are visible immediately. Others remain hidden for decades. And sometimes, the true cost of progress is only understood long after the machines themselves have fallen silent.